am Jacob Leong. Okay, I will teach you Mathematics Form 4, Chapter 1, Quadratic Functions and Equation in One Variable. And then subtopic that I want to discuss with you is 1.1 A, B, C, D, and E. The first learning standard for today is identify and describe the characteristics of quadratic expressions in one variable. What is quadratic expression in one variable? A quadratic expression in one variable is an expression whereby the highest power for the variable is 2. So remember, the highest power of the variable is 2 for quadratic expression in one variable. And then the graph of the quadratic expression is either in U shape or N shape. It has the highest point and the lowest point. The general form of a quadratic expression is ax squared plus bx plus c. So you look at here, the highest power is 2. A, B, and C are constant, and remember A cannot equal to 0, and x is a variable. Besides x, other letters can be used to represent variable. Let's say here, okay, you can use another letter to represent x. Let's say example, ay squared plus by plus c. The values of constant b and c can be 0. Look at here, this one, a cannot be 0, a at here cannot be 0, but b and c can be 0. For example, x squared plus 2x minus 1. So a here, 1x squared, a is 1. Okay, x squared plus 2x, so b is 2, and then negative 1 is c, okay? Second, negative x squared, negative y squared plus 3y. Okay, here, a should be negative 1, and then b should be 3. The third one, 1 over 3m squared minus m plus 4. A equal to 1 over 3, b equal to negative 1, c equal to positive 4. 2n squared plus 5. A equal to 2, b at here is 0, and then c equal to positive. Determine whether each of the following expression is a quadratic expression in one variable. If not, justify your answer. Okay, now we look at the example one by one. Okay, the first one, 2x squared plus 5. Okay, 2x squared plus 5 is a quadratic expression in one variable because a equal to 2, and then the highest power is 2, and then b can be 0, c is positive 5. Okay, b, x cubed minus 6. X cubed minus 6 is not a quadratic expression because the highest power, you look at here, the highest power is of the variable of x is 3. Because the quadratic expression for the highest power only 2, cannot be 3. So this one is not a quadratic expression. Now we look at C, 3x squared plus 2y plus 1. 3x squared plus 2y plus 1 is not a quadratic expression in one variable because there are two variables. Two variables being here, we have y, first variable, and then second variable is y. Quadratic expression in one variable only can accept one variable, not two variables, okay? Now we look at D, 1 over 2m squared. 1 over 2m squared is a quadratic expression in one variable because the highest power is 2, and then a equal to 1 over 2, b can be 0, and c can be 0. E, 2x squared minus 3 over x squared. 2x squared minus 3 over x squared is not a quadratic expression because there is a variable with a power which is not a whole number. You look at here, this one, the highest power is 2, But at here, this one actually negative 3 over x squared also equal to negative 3x power of negative 2. The power at here, the power is negative 2. So the highest power for quadratic only 2, not negative 2. So this one is not a quadratic expression. f(4x squared minus x power of 1 over 2). This one also not a quadratic expression because the power at here is not a whole number. The power at here is 1. All quadratic expression can be written in the form of ax squared plus bx plus c, where a is not equal to 0. Okay, this is the conclusion for today. And then in a quadratic expression, a is a coefficient of x squared, b is the coefficient of x, and c. Now we look at another example. Determine the values of a, b, and c for the subsequent quadratic expressions. Now we look at a. 2x squared minus 3x plus 1. From here, a equal to 2, b equal to negative 3, c equal to 1. For b, 2x squared minus 4. The first one, a equal to 2. We don't have the value of b here, so b equal to 0, and then c equal to negative 4. For c, a is 1 over 2, b is 5, c is negative 3 over 2. For d, a is negative 1, b is 1, c equal to 0. For e, a is negative 1, b is negative 3, c is negative 9. For f, a is 1 over 2, b 0. Okay, after you follow my lesson, you can try to do the self-practice about the quadratic expression in one variable, and then the values of a, b, and c and quadratic expression. For second learning standard, recognize quadratic function as many to one relation, hence describe the characteristics of the quadratic functions. What is the difference between a quadratic expression and a quadratic function? A quadratic expression is written in the form of ax squared plus bx plus c. And then quadratic function is written in the form of fx equal to ax squared plus bx plus c. This is the differences. Based on the graph of functions below, draw a line which is parallel to the x-axis. This one is the first step. Second step, mark the point of intersection between the graph of function and the straight line. The third step is state the number of points of intersection and the coordinates of the points of intersection. We look at A now. The first step is draw the parallel line to the x-axis. Which line is parallel to x-axis? And here you can draw y equal to 1, y equal to 2, y equal to 3, y equal to 4, up to you. Any line can be on the y-axis can be parallel to x-axis. Either you choose y equal to 1, 2, 3, or 4, up to you. So we look at here. I give you example for the question. Let's say I draw a line y equal to 4 here. Okay. After that, second mark the point of intersection. I draw like this first. The point intersection, the first one and the second one. The third question, state the number of points of intersection. This one is the first one, this one is the second. So we have 2 points of intersection. And then state the coordinate. The first one, 4, 4. The second one, -1 and 4. Now we look at second example. Also same. You draw a straight line that parallel to x-axis. You can draw y equal to 1, y equal to 2, y equal to 3, y equal to 4, and so on. You want to draw y equal to 2.5 also can, okay? But I choose whole number here. I prefer choose whole number. I choose y equal to 1. Example, I choose y equal to 1. So I draw a straight line parallel to x-axis, y equal to 1. And then mark 2 intersection points. The first one at here, and the second one is at here. How many number of points of intersection? We have 2 points of intersection. 2 points of intersection. And then what's the coordinate? The first one 0, 1, and then the second one is 4, 1. Okay, the last example for this part. Repeat the same step. Draw a parallel line. Okay, draw a line that parallel to x-axis. So I choose y equal to 6. Mark 2 points of intersection, the first one and the second one. So we have 2 points of intersection. We write 2 here. And then how about the coordinate? -1 and 6. The second is 4 and 6. According to the previous slide, we have to discuss 2 questions about the previous slide. Okay, the first one is, what is the relationship between the x-coordinate and y-coordinates of both points of intersection for each function? So from previous slide, we already draw the straight line that parallel to x-axis, and then mark the 2 intersections of the points. And then the third is we already state the coordinate of 2 points, 2 intersection points, right? So now we have to determine what is the relationship between the x-coordinate and y-coordinate. So all quadratic functions have the same image for 2 different objects. What is the meaning of same image but 2 different objects? So I use one example of the question from the previous slide. Okay, the first one. This one is the first example from the previous slide. Okay, same image, different object. Okay, from here, this one is x-coordinate. This one, 4 and -1 is x-coordinate. X-coordinate also is the object. And then 4 y-coordinate, here y-coordinate also 4. Y-coordinate is image. From the 2 intersection points, we have 2 different objects. That means 2 of these objects have different value. But for image, we have same value. So this is the conclusion. All quadratic functions have the same image, same y-coordinate, but for 2 different objects. Different object, that means 2 different x-coordinates. Question number 2. What is the type of relation for a quadratic function? The type of relation for a quadratic function is a many to one relation. What is the meaning of many to one? Okay, many to one, here, you look at here, object, we have two different objects, right? So there's many. And then we have same value for the image, so that is 1. So this is many to one relation. Look at this part. For the graph of function ax squared plus bx plus c, a is not equal to 0, there are only two shapes of graph, U shape or N shape. So how do you know this graph is N shape or this graph is with U shape? We have to look at the value of A. If A is greater than 0, that means the graph will be U shape. If A is less than 0, your graph will be in N shape. And then the curved shape of the graph, this one is the curved shape of a quadratic function. What is the maximum or minimum point of a quadratic function? Each sketch of the graph of a quadratic function has the highest or lowest value of y coordinate based on the shape of the sketch. So we look at the graph at here. We look at this one. Okay. For the sketch of the graph of a quadratic function with a less than 0, a less than 0, that means we have the graph of N shape. Okay. And then y1, we look at here, y1, this one, is the highest value of y coordinate. S1 is the corresponding value for y1, S1, S1, y1. So this one is the corresponding value. So S1, y1, this coordinate we call maximum point. We look at another graph. Okay. This one, for the sketch of the graph of a quadratic function with a greater than 0. A greater than 0, that means U shape. This one, N shape, a less than 0. U shape, that means a is greater than 0. We look at here, y2. Y2 is the lowest value of y coordinate. This one, y2, lowest value. And then S2 is the corresponding point. So the point of S2, Y2, this point we call minimum point. So this one is highest, maximum point. This one is lowest, minimum point. So you can make conclusion like this. Maximum point is obtained when a less than 0, and minimum point, we get minimum point when a is greater than 0. The maximum or minimum point we also call stationary point or turning point. So if I say stationary point, if I say turning point, that means that one is maximum or minimum point. What is the axis of symmetry of the graph of quadratic function? The axis of symmetry of the graph of quadratic function is a straight line that is parallel to the y-axis and divide the graph into two parts of the same size and shape. Okay, we look at the example of the graph first. You look at here. This one is axis symmetry, right? And then that means, okay, this line actually is parallel to y-axis. Okay? And then divide the graph into two equal parts. This one, the left hand side and right hand side have the same size, have the same shape. Okay? This one also same. The axis of symmetry will pass through the maximum point or minimum point. An axis symmetry of a straight line that divides a geometrical shape or an object into two parts of the same size of the same size and shape. Okay, this one already mentioned. Divide into two parts. Okay, and then for your knowledge, the equation of the axis of symmetry of a quadratic function, we have formula s equal to negative m to draw and recognize the axis of symmetry of the graph of a quadratic function. The first step is using a ruler, draw the axis of symmetry for each graph of quadratic function below, and then second, write the equation of axis of symmetry. So we look at a few examples. The first one already have answer. So we look at here, this one is minimum point. So we draw as axis symmetry and then pass through 1, so x equal to 1 for the equation of axis symmetry. For second example, the minimum point is at here, so you draw a line of axis of symmetry. After that, pass through -1, so the equation of axis symmetry is x equal to -1, and then this one is maximum point. Draw a line of symmetry, pass through the maximum point, and then we look at here, the equation of axis of symmetry is x equal to 1. So what is the conclusion that we can make? The axis of symmetry of the graph of a function is parallel to y-axis. You look at here, this one, this line, this one is y-axis, and then the line is parallel y-axis, this one is y-axis. Okay, axis of symmetry also parallel to y-axis, and also this one is parallel to y-axis, and pass through the maximum or minimum. This one pass through minimum point, this one pass through maximum point. For this part, this one is the self-practice. You can refer to the previous lesson, and then you can do the exercise yourself. This one determine the graph is in U shape or N shape, and then for second question, you have to state whether these two graphs. Okay, for this one is another part of self-practice, and then you can refer to the previous lesson also. Determine the maximum or minimum point. State the equation of axis symmetry. So you have to draw a line that parallel to y-axis, pass through maximum or minimum point, and then the third learning standard is investigate and make generalization about the effects of the changing the values of a, b, and c on graph of functions. The first one, we look at the changing in value of a first. Okay, we look at these two graphs. For the graph of a function, okay, the smaller the value of a, the wider the curve shape of the graph, and vice versa. So we look at the first example. The green curve graph is wider than the purple color graph, okay? But the A1, the value of A1 is less than A2. That means the graph is wider, the value of A is smaller. We look at this one wider, and then but A is smaller. This one, the Y of the purple, the A of the purple is, the purple graph is bigger. This one also same. We look at this one. The green graph is wider, right? But the A1 is smaller. The value of A is smaller. Wider, the value of A is smaller. And then for the purple graph, this one, the value of A is big. Okay, now we look at the value of B. Value of B determines the position of the axis of symmetry. We look at this one. If A is greater than 0, that means it's U shape, U shape, U shape, okay? If B is greater than 0, the axis symmetry is on the left of the y-axis. Less than 0, on the right of the y-axis. This one left, this one right. And then if B equal to 0, the axis of symmetry is on the y-axis. That means this one is axis symmetry in the middle, okay? How about A is less than 0? A is less than 0, that means it's N shape. Your graph will be in N shape, okay? So if B is greater than 0, the symmetry, axis symmetry, okay, lies on the y-axis of on the right hand side. This one right, and then B less than 0, the axis symmetry lies on the left of y-axis. This one left hand side. And then if B equal to 0, then the axis symmetry is the y-axis. So in the middle, y-axis is the middle, okay? Now we discuss about the value of C. The value of C determines the position of the y-intercept. Okay, y-intercept is a point that passes through or lies on the y-axis. So we look at here. A less than 0, the graph will be in N shape. And then C is at here. The graph passed through y-intercept. This one is y-intercept. So your value of C is at here. This one is a value of C. If A is greater than 0, this one is in U shape, the graph. And then the graph passed through y-axis is on here, cut on x-axis. So your value of C is at here. This one is your value of C, okay? That means if I give you the value of here is 2, that means C equal to 2, y-intercept equal to 2, like this. Now we look at a few related examples. Okay, the quadratic function fx equal to x squared minus 3x plus c passes through a point A as given below. Calculate the value of C. The first one, I give you coordinate A04. This one is S coordinate, this one is Y coordinate. If x equal to 0, that means this point is cut to y-axis. If cut to y-axis, that means x is 0. So you can write your answer. This one no need calculate, because if x coordinate is 0, that means the point lies on y-axis. So you just write C equal to 4 is enough, okay? How about this one? This one is x coordinate, this one is y coordinate. So you just need to substitute the value, the given values inside the function. X equal to -1, fx also equal to y, fx is y, okay? So y equal to 3, substitute inside, and then you can calculate the value of C, okay? Now we look at another example. The diagram shows two graphs of quadratic functions, okay? And then state the range of the values of P. Now this one, what's the value of P? This one, okay, we found that for this pink color graph, the value of A is 3, okay? A is 3. Okay, from the previous slide, we know that if the graph is wider, the value of A is smaller. If the graph is more narrow, this one pink color more narrow, the value of A is bigger. So the value of P at here should not be bigger than 3, okay? But from here, this one, because this graph is in U shape, A must be positive for U-shaped graph. but P cannot be bigger than 3 because the wider graph, then the smaller value of A. So how do you write the answer? The value of P is between 0 and 3, okay? U shape, you look at here, U shape, so P is greater than 0. Okay, P equal to A. And then the value cannot more than 3, so it's between 0 and 3, okay? Okay, this is the self-practice. You can try to do yourself. This is another self-practice. Try yourself. Try to do yourself. For learning standard number 4, form quadratic functions based on situations and hence relate to the quadratic equations. Okay, we look at the example. Mr. Ganesan plans to make 2 different types of cards for mathematics class activities. The measurements of the cards are shown in the diagram below. Okay, the first one, this one is in square shape. The length and width is XX, and then this one is rectangular shape. The length and width is 2x plus 1 and x. Form a quadratic expression for the total area. The area for the rectangular and for the square is length times width, okay? So you can write like this. Area A, this one represent area. Okay, you write A equal to x times x becomes x squared, and then x times 2x plus 1. Do expansion and then arrange in general form. So we get 3x squared plus x. For B, the total area of the 2 cards is 114. Form a quadratic equation in terms of x. So for your solution, the area equal to 114. So you have to write 3x squared plus x equal to 114. And then change to general form. So 114 move to the left hand side becomes negative 114. On the right hand side, you write equal to 0 here. So your answer is in. Another example. Ayman is 4 years older than his younger brother. The product of Ayman and his younger brother's age is equal to their father's age. The father is 48 years old and Ayman's younger brother is P years old. Write a quadratic equation in terms of P. Okay, we look at the solution. The first step, I will write like this. Okay. Ayman's age. You look at here, this one, this sentence. Ayman is 4 years older than his younger brother. So his brother is younger. His brother's age is P. So Ayman is 4 years older. So you just write Ayman's age is P plus 4. 4 years younger than 4 years older than his brother. Okay. After that, the product of his age and his brother's age is equal to their father's age. So P multiply P times P plus 4 equal to 48. And then you do it expansion. 48 move to the left hand side, and then this is your quadratic equation. The last learning standard is explain the meaning of roots of a quadratic equation. The root of a quadratic equation, ax squared plus bx plus c equal to 0 are the values of the variable x which satisfy the equation. Okay, now we look at a few examples here. Complete the table below. Now, x squared plus x negative 2 is on the left hand side, and then 0 is on the right hand side. After that, this is the value of x, so you just substitute inside negative 2 inside this quadratic equation, and then after you get the answer, this one is the left, okay, on the left hand side. If your answer equal to the answer to the value on right hand side, that means the variable x, the values of the variable x is satisfied the equation. Okay, so the first one, because this one is equal to 0, equal to right hand side, so this one, this value of x negative 2 is satisfy the equation. Okay, so we repeat the same step, repeat. After that, okay, we found that we have two values of x that satisfy the equation. So x are negative 2 and 1. And then the second one also repeat the same step. Repeat the same step. You look at here, this one on the right hand side, my answer is 2, right? So when I substitute inside, when x equal to 1, okay, you calculate, and then these two answer is equal to the given quadratic equation here on the right hand side, same, right? So x equal to 1 and x equal to 3 are two values that satisfy to the equation. So I write the answer here, x equal to 1 and 3. And then this one, you also calculate, repeat the same step. Compare, this one is on the left hand side, the quadratic equation. After you calculate, compare to the answer on the right hand side, and then equal to 1. Okay, so negative 3 and 1 is the are the values that satisfy the equation. So x are negative 1, negative. Okay, for your info, there are 1 or 2 values of the variable that satisfy a quadratic equation. So can be 1 value or can be 2 values. From the previous example, I only give the example for 2 values, okay? But we also have 1 value. I didn't give the example at here, okay? But you have to know, can be 1, can be 2. The value of the variable that satisfy a quadratic equation are known as the roots of the quadratic equation. So we call it the roots, okay? So 1 value also root, 2 values also 2 roots. We have 2 roots, okay? And then we look at this one. Okay, the roots of a quadratic equation, ax squared plus bx plus c equal to 0, are the points of intersection of the graph of the quadratic function fx equal to ax squared plus bx plus c, and the x-axis, which are also known as the x-intercept. Okay, the meaning of the sentence at here is, you look at here, you look at this diagram. If u-shape, okay, a greater than 0 is u-shape, right? So the roots at here on the roots is lies on the x-intercept. So this is 2 roots, okay? And then for a less than 0, also same. This one, a less than 0 is n-shape. The roots also lies on the x-axis. 2 roots are like this, lie on the x-axis. Okay. So we also call x-intercept. This one is the first x-intercept. This one is the second x-intercept. Also same with this one. The first x-intercept, the second x-intercept. Okay, now we look at this example. For each of the graph of quadratic equation, mark and state the roots of the given quadratic equation. So just now, from the previous slide, I already said the roots lies on the x-axis and then we call x-intercept, right? So now we look at the graph at here. This one is the first intercept, so your root should be -4, and then this one is your second roots lie on x-intercept also, so your value should be 1.5. For this one also same. Okay, this one, the first x-intercept or the first root x equal to -1, the second x-intercept here, and then that means the second root is 4. Okay, another example, determine whether each of the following values is a root of the given quadratic equation. Okay, I give you quadratic equation here, and then I give you two values. After that, you have to determine whether these two given values is roots for this quadratic equation or not. So how do you do it? Okay, right here. So the first one, when x equal to 1, this one is on the left hand side, you just substitute 1 inside here, and then you calculate, you get -2. After that, you compare to the right hand side is 0, right? So you look at here, left hand side, this one right hand side. Okay, left hand side is -2, right hand side is 0. That means x equal to 1 is not a root of the equation. Okay, for this one, okay, another value of x equal to 3, left hand side, you just substitute 3 inside the equation, you get 0. Your answer is equal to 0. And then right hand side also equal to 0. Since the left hand side and right hand side have the same value, that means x equal to 3 is a root of the equation. That means 3 is the root of this equation. Okay, so the second example also repeat the same step. Okay, left hand side is the equation, and then right hand side equal to 3. So the first value is x equal to 1, you just substitute inside, you get your answer is 1. But if you compare to the right hand side, the value is 3, right? So x is equal to 1 is not the root of the equation. 1 is not the root of the equation. Okay, so we substitute another value, x equal to 1/3 inside, you calculate, you get the answer of 3. If you compare with the right hand side also 3, right? So since the left hand side and right hand side have the same value, so x equal to 1/3 is the root of the equation. Okay, so that means must be balanced. The left hand side and the right hand side must have the same value, only that one is the roots for the quadratic equation. Okay, this one is that the roots you have to do yourself. This one is self-practice. You can refer to the lesson from the previous lesson. This is another slide of self-practice. You can refer to the example of the previous lesson also. Okay, okay, that's all for today. Hope you can try your best to complete your self-practice.